So now we're going to kind of switch gears a little bit, and we're going to talk about integrals of trig functions. So we're going to look at the following example. We know the integral of sine and cosine, but now let's talk about the integral of tangent. So we can think about tangent as a quotient. It's sine over cosine. And now, because we've looked at this u substitution, we can do a u substitution here, u being the denominator, cosine. The derivative of cosine is a minus sine. Well, if I look here, I have sine x. I don't have a negative there. So if I multiply this equation by -1, I'll get negative du is positive sine x dx. And now I'm ready to make my substitution. So the integral of tangent is 1 over u. That's what we get when we plug in u for cosine. And then the rest of it, sine x dx, becomes a negative, which I'll pull out in front, a negative du. So now I'm getting negative, the integral of 1 over u is ln of u plus c, and then plug back in, u was cosine x. So there is the integral of tangent. All right, we're going to look at another trig function, integral. So let's look at, find the integral of secant. So I don't know a function whose derivative is secant, so we're going to need to do something to compute this integral. And we're going to do something special. It might seem weird for the moment, but this is kind of like a trick that's going to work here. And so I'm going to multiply, think about this as being secant over 1. I'm going to multiply by secant x plus tangent x on the numerator and denominator. So essentially I've multiplied by 1 because the numerator and denominator are the same, so this is equal to 1. So I haven't changed anything. And now I'm going to distribute in the top, in the numerator. I'll get secant squared plus secant tangent over secant plus tangent. And now I can do a u substitution. So what's my u substitution going to be? U is going to be the denominator, secant x plus tangent x. The derivative of that, the derivative of secant, is secant times tangent. The derivative of tangent is secant squared. And that's exactly what we have in the numerator. So when I make this substitution here, I'm going to get u in the denominator, and then all of this stuff in the numerator, I'll circle it so we can see it, all of that is going to be replaced by du. So now I just need to integrate 1 over u, which we've already seen a few times. This is the natural log of u plus c. And again, you plug in back for u, secant x plus tangent x plus c. And there is my answer. So again, for this very special integral, for secant of x, we had to do this special trick where we multiplied by secant x plus tangent x in the numerator and denominator. And after we did that, we were able to do a u substitution and compute this integral. So now that we've done a couple, I'm going to state all of our trig integrals. So the integral of sine is minus cosine, and the integral of cosine is sine. These were two that we knew before. We just did the integral of secant. It was ln of secant plus tangent. You can also find the integral of cosecant in a similar way to the way you found secant. So it'll be minus ln cosecant plus cotangent plus c. And then we have the integral of tangent, which we did earlier. It was negative ln of cosine. And then the integral of cotangent, which is ln sine x plus c. So these are the integrals of the 6 trig functions. You probably want to have these out to reference when you're working on trig integrals. Okay, so these formulas are very important. They're definitely things that you want to keep in mind while computing trig integrals.